We're going to learn a couple of counting techniques in the next couple of videos, and one of the reasons you need counting techniques is you need a way to assign a number to a particular event that represents that event's probability. And so to get that probability, you need to know how many elements are in the set that contains all the possibilities for the particular event. So some examples of this would be like if you wanted to calculate the probability of winning a lottery or a raffle. Or let's just say you wanted to guess the correct answer on a test question, or you wanted to know the probability of selecting a particular card from a deck of cards, or the probability of rolling a particular number if you roll a pair of dice, the probability of having a boy or having a girl, the probability that a light bulb or a battery or some other object will last more than 1,000 hours, the probability that you will wait in line more than 15 minutes at a fast food restaurant, the probability that an item will have a defect within the first year of use, and then there's all kinds of areas where we have to calculate probability. Well, how do you find the probability of an event? Simply put, you take the number of ways that your event can occur and divide by the total number of possibilities. Now this makes an assumption that each event is equally likely to occur. If that's not the case, then you have to do it a little differently. But on the events that are not equally likely to occur, like I just said, we take a different approach. So being able to count the number of elements in a set is a very important tool for probabilities. So, for example, suppose you toss two coins. What's the probability that both coins are heads? Well, in this example, we can assume that each event is equally likely. So, what are the possibilities? The total possibilities are you could toss them both heads. The first coin could be heads and the second coin tails. Or the first coin could be tails and the second coin heads. Or they could both be tails. Well, if we assume that each of these four events is equally likely, then we could say, okay, how many ways are there to get the event that I want, which would be two heads. So there's only one way that could happen. So there's one way out of these four ways possible, so the probability would be 1/4. Now in other examples it's not so easy, because things like how many hands are possible in a 5-card draw from a 52-card deck, or how many possible lotto combinations are there, and things of that nature, you couldn't actually take the time to write them out, and so that's why we need these counting techniques. So these counting techniques are going to give us ways to count how many elements are in a set without actually having to count them. And we actually have 4 counting techniques: the addition principle, the multiplication principle, and then we'll talk about permutations and combinations. So before we get into that, let's recall some of the terminology about sets we discussed later. So this is just a review. So remember that U represents the universal set. So if we selected a card from a standard deck, U would be the set containing all 52 cards. Now, but if we selected a 3-card hand from the deck, U would be the set containing all 3-card hands. So U has to be the set of all elements that's being considered. This notation would be the set A union B. So for instance, if the universal set were these shapes: circle, triangle, square, pentagon, hexagon, heptagon, octagon, diamond, heart, and star, then let me just make up 3 sets here. Let's say that A is the circle, triangle, square, hexagon, B is the octagon, square, diamond, triangle, and C is the pentagon, the heart, and the diamond. Then A union B would be just the combination of everything that's in A with everything in B, and of course you don't duplicate it. And A union C would be everything in A combined with everything in C without duplicating anything. And then the other would be the A intersect B. Remember, that's all the elements that lie simultaneously in both sets. So if we go back and use these sets up here, A, B, and C, like we did before, and A intersect B, the elements that are in both of these sets would be the, let's see, A and B. We have the triangle that's in both, and we also have a square that's in both. So the intersection of A and B there would be the triangle square. And then B intersects C. It looks like the only intersection is the diamond. Okay? And then remember, A prime are those elements that are not in A. So if you wanted to know what A prime was, then you would just go ahead and go back to your universal set and remove everything that's in set A from the universal set, and then that would give you A prime. And then likewise with B, you would get the universal set, remove everything that's in B from the universal set, and that would give you B prime, and similarly for C prime. And then remember, the capital letter A defines the set, but this notation with the little n of A is the notation to give the number of elements in the set. So since set A had circle, triangle, square, and hexagon, we know the number of elements in that set is 4. And since A intersect B had a triangle and square in it, we know the number of elements in that set is 2. And then go back to A prime, there was 6 elements in A prime, so we could say that the number of elements in A prime is 6. And then the last couple things to remember is that this represents the empty set, and that sometimes you have elements that don't have anything in them, so then that would be the empty set. And then remember that lowercase letters generally is used to represent the elements that are in a set.